Hello, today we are going to talk about the few chemistry topics that the ACT Science wants you to know. First, we'll start with the basics of all chemistry. You, me, the device you're watching this on, the pencil, the sky, all of these are made of things called atoms. Atoms are particles made of protons, neutrons, and electrons. Protons are positive, neutrons are neutral, and electrons are negative. Protons and neutrons are clustered together in the middle of atoms in a part called the nucleus, and electrons orbit around this nucleus. There can be many different types of atoms. These atoms can have different numbers of protons, neutrons, and electrons. Scientists group types of atoms into what we call elements. Elements are types of atoms with a certain number of protons and neutrons. For example, hydrogen, or H, is a type of atom with one electron, one proton, and 0 neutrons. The periodic table shows many different types of atoms. Hydrogen, or H, is right here. When you read a periodic table, you notice that there is a number on the top to show the number of protons that the element has. That's why hydrogen, which is right here, has a 1 because it has 1 proton. On the ACT Science, you do not need to know how to read a periodic table, but it is important to know that there are many different types of elements and different atoms exist, and that elements have different masses. Atoms can bind together to form molecules. For example, a water molecule is made of 2 hydrogens and 1 oxygen. We express this in what we call a chemical formula. So the chemical formula for water is H2O. Notice again how there are 2 hydrogens. So by the H, there's a 2 written, and 1 oxygen. H2O, or water molecules, are linked together by what we call covalent bonds. In this bond, all atoms share electrons. Different molecules have different masses. For example, CO2, which we call carbon dioxide, has a molar mass of 44.01 grams. This is the case because we're going to add our 1 carbon atom plus our 2 oxygen atoms. So carbon has a molar mass of 12.01. And remember, molar mass is how much it weighs. And oxygen has 16. So if we add 12.01 plus 16 plus 16, then we get 44.01 grams per mole. So again, we can see the same thing is true up here for H2O, or water. Hydrogen has a molar mass of about 1.0079, and oxygen 15.994. So if we add 1.00794 plus 1.00794 plus 15.994, we get the molar mass of 18.0528 grams per mole. Now, because of this, we know that water then has a molar mass of 18, and carbon dioxide, CO2, only has a molar mass of 44.01. So we can say that carbon dioxide weighs more than water. Remember, you don't need to memorize or know on the top of your head the specific molar masses of any of these elements. But you should know that hydrogen atoms are very light, they weigh very little, while oxygen atoms, which are 15.994, they weigh more than hydrogen and carbon, which weighs 12. Notice how for both of these, it's about the same. You're just rounding. So because of this, we can say that H2O is lighter than CO2. A neutral atom is an atom that has the same number of protons as electrons. If you take away electrons, then it's going to be more positive. And if you get more electrons, it's going to be more negative. So for example, in this example, we have 5 protons, but only 3 electrons. So because there are more protons than electrons, the atom is positive, and we call this atom a cation. In this example, we only have 3 protons, but 5 electrons. So because there are more electrons than protons, we call this an anion, which is negatively charged. You see cations and anions in types of bonds called ionic bonds. And unlike covalent bonds, where 2 elements share electrons, in ionic bonds, one element gives an electron to the other. And that means that if, for example, Na, what we call sodium, gives its 1 electron to Cl, which is chlorine, then Na is going to be positively charged, a positive cation, and Cl is going to have an extra electron, so it's going to be a negatively charged cation. A good way to think of ionic bonds is to think of a magnet. In order for a magnet to stick together, right, we need opposite sides. So opposite sides attract and same sides repel. So Na and Cl are negatively charged, or Cl is negatively charged, Na is positively charged, so they're oppositely charged, so they're going to want to stick together. So again, if both sides are positive, they will repel. If both sides are negative, they will repel. But if both sides are an opposite charge, they will attract. So the density of an object is how much space it takes up relative to its mass. In other words, the density of an object is how much mass it has over how much volume it has. So think of a suitcase. So one suitcase is stuffed with clothing, while the other has no clothes. So they're both the same size, right? But they have different types of clothes or numbers of clothes in them, right? So this suitcase is more densely packed, even though the volume of the suitcase, how much stuff can fit in there, is the exact same. So we'd say that this one is more dense than this one. And a fun way to remember D equals MV is to think of it like a heart.